Hi, my name is Franz Vargas and I live in San Jose, Costa Rica. Today I'll be talking to you about microphone basics. There are three main things you should know about them: the type of microphone, the frequency response, and the polar pattern. So let's start with type. There are a lot of types of microphones: condenser, dynamic, ribbon, laser, but the two most common ones are dynamic and condenser microphones. They differ in various aspects. For instance, condenser mics need extra power in order to function. Dynamic microphones, they do not need this extra power. This power is called phantom power, and it's usually 48 volts. Other aspect in which they differ is the sensitivity. Dynamic microphones are less sensitive than condenser microphones. Condenser microphones usually pick up better better top end hiss of the sound and the big low deep part as opposed of dynamic microphone. The third aspect is resistance to abuse and care of them. Dynamic microphones can withstand a lot of abuse. They tend to be used in stage environments in which they will get beaten and thrown and get sweaty and all. They are very resistant. On the other hand, condenser microphones are not that resistant. They are very fragile. You really have to take care of them. Frequency response is the sensitivity to the different frequencies in the whole spectrum. The human hearing goes from 20 Hz to 20 kHz. So microphones tend to try to capture as much of this frequency as they can, without emphasizing or de-emphasizing some frequencies. This type of response is called a flat response. You can see in this picture that the of the Audio-Technica AT2020 frequency response is pretty flat. It doesn't emphasize or de-emphasize much on frequencies. On the other hand, on the opposite side of the field, we have the iPhone, which the first iPhone tend to cut the regional one tend to cut frequencies above 4 kilohertz and below 100 kilohertz. So that's why you tend to sound the phones tend to sound so boxy, because they don't capture this high end or bottom end, just the middle part. The third thing you should know is the polar pattern, and this refers to the sensitivity, but not of the frequency itself, but of the direction from the sound that the sound is coming from. For instance, the most used is the cardioid one. The cardioid is named like this because it's shaped like a heart. So as you can see, in this picture, you can see from where direction, from what angle the sound is better picked up. If I start to move to the right, you tend to see that the sound is slowly going down in volume, less and less volume. Even if I move all the way to the back, there's almost no sound picked up by the microphone, just the room and how the echo of this place works. There are a lot of polar patterns and variations of them. For instance, we have the cardioid one, that's the one I showed you. We also have the subcardioid, we have the supercardioid, the hypercardioid, and that's all the three variations. We also have the omnidirectional one, which means it picks up sound from any direction that the sound is coming from. For instance, this lavalier mic that I have right now, it's omnidirectional, so I'm gonna switch to that sound. And as you can see, I can move the microphone in almost any direction I want, and the sound is gonna be picked up. No matter where the sound is coming from, it picks up in the same volume. That's why it's omnidirectional. So coming back to my main microphone, that's the omnidirectional. There are other types. There's also figure 8 or bidirectional, which means it catches sound from the front and the back of the microphone, and also the shotgun or unidirectional microphone. It only picks up in a certain direction, certain specific directions. So these are the polar patterns we have.